Hey, hi, this is Sabita Sunkara. On today's SQL interview question, we are going to discuss a real production issue that many experienced SQL developers face. So, imagine your stored procedure runs in 2 seconds today, but tomorrow the same stored procedure takes 40 seconds. There are no code changes. The SQL server is the same thing. The database is the same. So, why is it behaving differently? So, let's understand one of SQL Server most common performance issues, parameter sniffing. Okay, the scenario is like suppose we have a stored procedure called USP underscore get employees. So yesterday it completed in about 2 seconds. Today it takes 40 seconds. Nothing has changed in the code. So as a SQL developer, the first question should be why is the same stored procedure giving different execution times? The answer may be parameter sniffing. Let's see how it happens. SQL Server does not create a new execution plan every time. Instead, during the first execution, SQL Server looks at the parameter value. For example, execution USP get employees at the rate department equal to HR. Suppose the HR department has only 100 records. Then what happens? SQL Server creates an execution plan optimized for those 100 rows and stores it in the plain cache. Later, another user executes the same procedure with department equal to sales. Now, the sales department contains 5 million records. So, instead of creating a new execution plan, SQL Server reuses the old cache plan that was built for only 100 rows. So, because of that reason, plan is not suitable for a large data set. The stored procedure becomes very slow. So, this behavior is called parameter sniffing. So, let's compare both executions. First execution, department equal to HR. So, we have only 100 rows. SQL Server chooses an index seek. So, execution time is around 1 second. Everything works perfectly. Now, look at the second execution, that is department equal to sales. So this time there are nearly 5 million rows. So then what happened? SQL Server still uses the same execution plan that was created for the HR department. So instead of choosing a better plan like a scan, it continues using the old plan. So as a result, what happened? CPU increases, logical rates increases, execution time jumps from 1 second to nearly 40 seconds. The problem is not the stored procedure. The problem is execution plan reuse. Then how we can fix this? Parameter sniffing. Okay, now let's see. The option 1, we have recompile. So this forces SQL Server to generate a new execution plan every time the stored procedure runs. Here we can see the pros and cons. So about pros, that is advantages, always gets the best execution plan and great for parameter sensitive queries. But the cons is, that is disadvantage, extra CPU uses because SQL Server recompiles each time. Then the solution 2 is optimize for. So this tells SQL Server to create the execution plan using a specific parameter value. In that also we have pros and cons. One is, advantage is stable performance for common parameter values. But the disadvantage is not suitable if data distribution changes frequently. Okay, then the third one is local variables. So If you assign the parameter to a local variable before using it, so this sometimes prevents SQL Server from using the sniffed values. So pros is simple solution and the cons is it may produce a generic plan that is not always optimal. And the fourth one is, update statistics. So sometimes outdated statistics lead SQL Server to choose a poor execution plan. So updating statistics helps SQL Server estimate row counts more accurately. Here the advantage is better cardinality estimates and better execution plans. The only disadvantage is does not solve every parameter sniffing problem. It depends. And now the fifth one is query store. Let's you compare execution plan and even force a good plan in production. So in this, advantage is excellent for troubleshooting, great for production systems. And the disadvantage is requires SQL Server 2016 or later one. Then the sixth one is rewrite the query. So sometimes rewriting the stored procedure or splitting logic for different parameter values is the best solution. So always choose the solution based on your workload. So there is no single fix for every scenario. In the real time, if you face the issue in production, follow this checklist. First, check the actual execution plan. Then compare the estimated rows with the actual rows. Then check whether SQL Server is reusing an old execution plan. Then verify if statistics are updated. After that, look at the parameter values passed to the store procedure. Then use query store to compare execution plans over time. Then the interviewer asks, why is the same stored procedure fast sometimes and slow sometimes? Then you can answer, SQL Server catches the execution plan generated during the first execution. If later executions use very different parameter values, then SQL Server may reuses the same catched plan. When the data distribution changes significantly, that plan may no longer be optimal, then causing inconsistent performances. This behavior is called parameter sniffing. Also, you have to explain how would you troubleshoot it using actual execution plan, query store, statistics, and parameter values, these things. So this demonstrates practical production experience. Parameter sniffing is not a bug, it's a how SQL Server optimizes query execution. The key is understanding when plan reuse helps and when it hurts. Thanks for watching. Subscribe for more SQL advanced interview questions and real world performance tuning concepts. Thank you.